Hello, everybody, and welcome to another SPE Live. I'm your host, David Gibson, and on this SPE Live Tech Talk, we're going to be diving into things here today with Tetra Technologies. We're going to be looking at some of the solutions out there for sand management. Yes, we're not talking about making sandcastles. We're talking about things in the oil and gas industry. All right, so today's live stream, obviously this is live. So what we want to be able to do, and the whole reason we do this live, is we want to be able to interact with you, the audience. So number one, let us know where you're watching from, right? We want to be able to see where all the people around the world are getting their information from here at SPE, as well as if you have any questions for our experts at Tetra Technologies, be sure to ask them in the comment section. We'll be sure to address those and be able to get to them. And even if we don't get to them on the air, somebody from Tetra Technologies should be reaching out to you shortly afterwards. All right, so let's go ahead and bring on our expert of the day. So a major issue facing many production engineers in sand management, there are obstacles equipment has historically been unable to overcome, and prolonged use is costly. Today, we explore both tangible and economical solutions for sand management and post-frac production. Joining me for the Tech Talk is Adam Colvin. Adam manages the production, testing, and fluids business in the central U.S. for Tetra Technologies. One of his primary focuses is technology and business development within the flowback surfaces. Adam, thanks for joining us.
David, thanks for having me. Happy to be here.
So tell us a little bit about, what are the, what are some of the shortcomings in the sand management area?
Yeah, so in short, the equipment that's been deployed historically is not capturing the sand that's produced these days. And the issue really is twofold. The completion design has changed the last couple of years. Operators are using smaller mesh proppants. 100 mesh is very common, whereas larger proppants were used in the past. Additionally, they're capitalizing on cost savings by using in-basin sands that have lower crush points than some imported materials out of the northern areas. So the combination of these two things are a very small product coming back on the production side of things. The historical equipment that's been used has been unable to capture it. Operators and service companies are responding by deploying additional equipment in series, which is resulting in increased costs and increased labor associated.
So with increased labor association, increased labor costs and having these items in series, what are the solutions to be able to overcome those things?
So I think before we look at the solution, I'd like to talk just a little bit about kind of the history of what's been used and why it's not adequate today. If you look back a couple decades, sand management really just consisted of slowing down those fluids, allowing gravity to drop those solids into a vessel, and then you would have a solids-free fluid leave the vessel and go downstream. But as that particle size has gotten smaller, especially as it's become crushed during the hydraulic fracturing process, these solids are passing directly through these vessels. They're capturing very little. The next iteration of the technology, even before the introduction of 100 mesh, was people offset the inlet on these vessels and created kind of a circular motion inside of them. And the goal was to sling those particles to the entire diameter of the vessel. The particles would fall to the bottom. Again, the solids-free fluids would exit the vessels. The issue with these cyclonic style traps, which are very common on the market today, is they're not sized properly for the particles that we're trying to capture and the flow rates that we see. From there were some companies that brought spherical traps to the market. They performed a little bit better, but again, very similar process and really just weren't sized properly. The spherical traps, unfortunately, had the added disadvantage of becoming packed off if you filled them too full just by their shape. Another solution that was common for a period of time was filter systems. Filter systems do a great job of removing sand, but unfortunately, as they become packed off, they start seeing higher differential pressures, which result in lower production numbers, and cleaning them can be very labor intensive and time consuming as well. So in addition to those systems, we also have trialed some dynamic systems. We brought some systems in from overseas that were extremely complicated, had a motor on it and a shaft into the vessel and basically slung the particles to the exterior They work well, but just really weren't robust enough for the in-basin applications. We tested it and broke it just about every way imaginable. In addition to that, they're very cost prohibitive. And then lastly, we want to discuss just the horizontal slope gravity separators. They operate very similar to the first one we discussed, where you're relying on gravity to separate these particles. However, they've limited the distance that those particles have to fall from feet to inches. These worked well enough, provided you didn't have an oil emulsion. Any type of oil emulsion would carry those particles directly through.
So this is some of the historical equipment. So where are we at as far as what's available on the market today to be able to solve some of these historical issues?
Absolutely. So Tetra has trialed or owned every one of these systems that we just mentioned. Our engineering team recognized the shortcomings of all of them and set out to design and deliver a solution that could get the efficiencies without having the back pressure. And what they determined is that a properly sized hydrocyclone trap can do that. And so that's exactly what they did. They looked at what are the particles that we're seeing, right? That's 100 mesh, which is 149 micron, and smaller as it's crushed during the hydraulic fracturing process. We looked at some of the flow rates within the basins and said, okay, these are the flow rates that we need to be able to capture these particles efficiently. And they designed a properly sized hydrocyclone. It's also important to note that this design does not impart any type of flow restriction on the well and doesn't limit the production, doesn't choke back the flow. So the solution is our Sandstorm advanced hydrocyclone.
So what are some of the examples of like case studies that you guys have gone through where you've seen success with being able to implement this technology?
Yeah, so we first brought the technology to market in the Permian a few years ago. We started product testing. We were very pleased with the results. Since then, we've went into a production mode. We've deployed these units in every major shale basin in North America, and the results have been the same. We're capturing 97+% of all solids in the flow stream. That's again 100 mesh and crushed 100 mesh. Whether that's a gas market or a liquid market, low pressure, high pressure, low flow rates, high flow rates, we can tailor these units with some interchangeable inserts, and we can really achieve very, very high efficiencies despite the market.
So let's say that I'm a production engineer, which I absolutely know nothing about. Let's just be honest here. And you're watching this. Let's say that you've now got your sand management solutions under control. What's next out there for a production engineer to start looking at then?
Sure. So even before we started tackling the efficiency issue, we recognized that sand production, especially with the introduction of 100 mesh and smaller proppants, it lasts a very long time. There's equipment needs and personnel needs for months at a time. In extreme cases, we're seeing equipment stay on location for over a year. Very costly. And so we've done our best to design equipment that limits the amount of equipment on location, but there still is a prolonged labor period where you have people on location dumping these traps during the high sand production periods. So what Tetra looked at was ways of automating that dumping process to where that handover from manned to unmanned can happen sooner.
Excellent. So we did get a question that came in here from Valdez Gomez. It says work pressure ? And gas wells ? So were we able to do this on both oil and gas wells?
Absolutely. So really the efficiency is a function of velocity. And so when we're trying to determine whether or not this unit is going to be efficient, what we're looking at is velocities. And so that velocity can come from gas, it can come from liquids, and we can separate really anything depending on whether we have enough velocity. As far as working pressure, we have units that are in 5, 10, and 15,000 pounds.
So we got another question in here from Marcio. It says, how do you flush out the solids and also manage this material?
Sure. So the solids are accumulated in a chamber below the separation process. And so once those solids accumulate to a certain point, those solids will be removed, typically to an open top tank. In that open top tank, there'll be a slurry of both liquids and solids. Excuse me. Then a hydrovac or a vacuum truck will suck up that liquid and those solids and take it to a disposal.
All right. All right, so back to one of my original questions, as far as like labor, the labor intensity that goes along with some of these older solutions. How really is that gap bridged between y'all's new sand trap technologies versus what there used to be out there? How did you guys actually go about combating that problem of reducing the labor intensity?
Sure. So as mentioned earlier, the solution to this problem for a period of time was just adding more equipment. So instead of running one sand trap, you'd run two sand traps. There were some operators that were even running large diameter multi-phase vessels downstream, not really to separate phases, just to add retention time to drop these solids out. And so as you add this equipment, you're adding labor, you're adding costs, you're adding flow line, you're adding a lot of things that add cost. And so if you have a solution that's capable of removing 97 to 99% of all the solids in just a single pass, now you don't have people operating those downstream pieces of equipment. And so, you can see a 2/3 reduction in your labor force by running a system that's capable of capturing it with one pass.
So how did that even come about, where they were just like, let's just start adding 2 to 3 pieces more of equipment instead of just trying to rethink that individual equipment? So was there like a cultural change that took place either on the Tetra side or on the operator side to be able to kind of rethink that solution?
So I think sometimes, when you're dealing with operators, the completion side has an objective and the production side has an objective, and they don't always talk with each other. So completion found a way to frack wells cheaply, and then the sand production became the production team's problem. And so they just reacted as fast as possible with getting this sand removed from the flow stream. The alternative is that you allow it to go to your production facility. The production facilities fill up. You have to shut in. There's downtime associated with that. You could potentially start washing out flow line, washing out pumps, and then you have remediation costs, potentially loss of primary containment and environmental impact. So it was a real issue, and it was really left to the production team to solve.
So obviously, with a technology like this, where you have, I come from the drilling side, so where it's like, drilling creates a problem, then it becomes something for completions and for production. So for this solution to be able to get this implemented, were you guys talking more so with the completions or the production team? And was there a challenge in being able to kind of get this sold or to be able to get some of this kind of implemented with clients? And were you having to kind of break down the silos within the operator's office and say, hey, can you two guys come into the same room and understand that we're trying to solve problems for both of you?
Sure. I think every organization's a bit different. Siloed is certainly a good word. Some operators that they communicate well between the handover between completion and production. We see sometimes that this work is called out by the completion team and then eventually handed over to the production team. I think both sides have a vested interest in it and have been receptive. I just think that, you're not going to change the mind of a completion engineer to use 100 mesh in basin 100 mesh just because production's having some issues with capturing it on the backside.
Well, so we've got an interesting question here from Dr. Nils. It says, can this technology be used for sand removal in conventional production wells where formation sand/fines are being produced? So obviously, normally, a sand management is something associated with unconventional wells, but obviously you could have unconsolidated sands in conventional wells as well. So is there a crossover for the technology?
Absolutely. And we've been looking at different applications, not necessarily at the well site. We've been looking at some solids removal within pipelines. As I mentioned before, it's really just a function of velocity. So provided you can provide the velocity that's required, we can target particular size solids. So absolutely, as long as you have flow, you will have separation.
Well, since this is the tech talk, let's dive a little bit deeper as far as what the needs are on the velocity side of it. And can you explain a little bit more for, us laymen who've never been on a frac site before? What exactly does that mean, and what are the different velocities that can be seen?
Sure. So, flow rates definitely, again, I say flow rates. Flow rates are ultimately velocity. They vary pretty widely. If you look at the Midland Basin here in the Permian, you can see flow rates as low as 1,000 barrels a day or lower on initial production. You go out toward the Delaware Basin, and you can see flow rates, with equivalent barrels, upwards of 30,000. So that's a pretty wide range. And so what we've done, we've designed several different inserts that we can install to tailor that separation based on what flow rates you expect to see.
Excellent. And so I want to be able to take a step back and see, because we were talking about it. As far as the design and evolution of this, what really triggered the moment for you guys to be able to start designing this product?
So we have a very proactive engineering team, years of experience. One gentleman individual, or in particular, had worked subsea and dealt with hydrocyclone systems in the past. And so it was really just him observing and the team observing an issue and coming up with a solution. We made it unique by some of the interchangeable and wearable parts. Again, the modular nature of this, to where we can swap these out quickly, that they service a very wide operating envelope of flow rates. And so it was a bit of a proactive discussion, but also reactive, based on customer input.
So what was some of the customer input that you guys were getting to be able to start down this journey?
So we had the cyclonic system, not the hydrocyclones. And so it was, hey, the one is not catching it. We need two. And now we need a large multi-phased test separator. And is there any way that we can do this better to alleviate some of this equipment and personnel requirement? And so with those discussions, we went to the engineering team, and they said, well, we've already kind of been working on some of that. And here's what we're thinking about. And so we got some units together and trialed them, and they performed very well.
All right. So speaking about how to be able to do this on obviously on the conventional side, whereas most offshore stuff is a conventional reservoir. So Valdez asked a question: footprint increase and deck load offshore will no be a problem. So will that not be a problem, or would that be a problem for deck space?
So actually, because we've really shrunk down the separation process, the separation process is very small. It happens in about a 3x3 package. Then you have an accumulation chamber that just stores the solids. And because we've reduced the size of the separation process, we've actually been able to reduce the size of our vessels by 50%, because now all they're doing is capturing the solids. They're not actually, or they're holding the captured solids. They're not involved in the process of capturing them. So we've been able to reduce the footprint on the Sandstorm. We can actually fit 4 of these units on a single truck. They weigh just a little bit less than 10,000 pounds. So they're very compact, and there's some significant logistic cost savings with these units over somewhat else on the market, in both logistics, and then also how do you set them, whether you can use a forklift or if you need a larger gin pole with some of the larger trucks. But I can assure you that, yeah, whatever is conventionally on the market, this is very likely smaller.
I think it's funny to hear somebody be able to say that something that weighs 10,000 pounds is compact. Only in oil and gas would that be said, right?
Sure. Well, considering the others are close to 20, it's a pretty small one.
Wow. So y'all definitely got that one on the onto the treadmill to slim it down. All right, so we've got another question here from Dr. Nils. Is separation efficiency influenced by dual phase oil water or multi-phase oil gas water flow?
So yes, but not as much as you would expect, right? So as long as you have that velocity again, and you've sized that system properly, whether you have oil emulsion or if it's a gas, you're going to impart the forces required on those particles to sling them to the exterior and drop them into the vessel. So yes, it's going, obviously particles are going to move through a gas easier than they are water or oil. But again, we've modeled these to remove sand from oil emulsions, which is about the most difficult thing you can do.
So it's interesting you say that. So having to be able to resize these, what kind of time frame, as far as, let's say that you guys get called right now to be able to go out to a job, what information does that operator need to be able to give you to be able to get set up? Or is more of the setup and preparing to be able to do this operation, is that taking place out at the field level, out at the rig site?
Sure. So we're pretty familiar with the expected flow rates depending on the basin. However, prior to deploying units, we like to have a conversation with the operator to determine, what are their flow rates going to be early stages, what are their flow rates going to be, average, and then what are the peak flow rates they expect to see. And we attempt to select an insert that's going to service all those different variables the best that it could possibly do.
So how, in that case, would you measure to be able to say that, you guys just finished a job? How would you say that it was like high five worthy success for Tetra Technologies?
Sure. So, for a period of time, we were installing downstream equipment to quantify the carryover or lack thereof. And so we don't see that anymore because we're really just installing a single sandstorm typically, and then going right back into the sales line. But the absence of solids at the production facility is really the easiest way to gauge that. Operators, while it's operating, will go out with thermal cameras. They'll look at their separators. They can normally see a temperature interface if those separators have started to fill with solids. So there's some things you can do to quantify the effectiveness real time. There's also some tests that you can do on the actual fluids where you do a little spin out to see if there's sand in the fluids. So even though we're not running a bunch of downstream equipment these days, we can still quantify that they are doing a great job.
So obviously, y'all's primary client then is the completions engineer, but it sounds like the production engineers would be the ones taking you guys out for dinner if things are going well. Are y'all still following up with production engineers afterwards and getting these reports from them and saying, hey, how did the 36H pad turn out for you guys out at the production facility? Did things look right? Is that part of the process?
Sure. Yeah. No, we deal with both the completions and production side and have very candid conversations with them. And they share with us that, it's doing great and we want more of them. And we've had some operators that, maybe want to tailor some inserts. And so we'll have that discussion. But yeah, absolutely. Very, very much a back and forth with both the completion and the production side.
So here's another question from Guillermo, which is a great base level question. Is it very essential issue how to decide where to use sand management or sand control tanks? Obviously, if somebody's new, because this happens a lot, you'll take somebody who's a drilling engineer and they'll get moved over to completions or production. If somebody is a new engineer, how do they need to be able to address the situation if they're completely new to it and need to know whether they should be giving you guys a call?
Sure. I think typically they'll have some idea whether they suffer from sand production issues. Some of these lower pressure reservoirs don't necessarily give up as much sand as others. I think that if you are concerned about it, it's easy enough to deploy one of these systems initially. And if, sand production rates aren't, an issue, then that equipment can be released very quickly. If they are an issue, then the sand's going to capture that, or sorry, the equipment's going to capture that sand and it's going to stay out of your production facility.
All right, and Valdez, who's going to be able to get the number one fan of the day for asking so many questions. So we do appreciate it. If anybody else has got any questions, be sure to throw them in there pretty quick. We're about to finish up, but if you do have a question, we do want to get to it. So don't be shy. There's only a couple of calories to type there on your computer. So Valdez says H2S and CO2 proof ? And max work pressure.
Sure. So they are NACE. They are sour service. They can handle high levels of H2S. They're designed and manufactured to an API 6A standard. Our maximum working pressure on any individual unit is 15,000 pounds. We have also 10,000 pound and 5,000 pound units.
Excellent. Like I said, guys, if y'all have any other questions, so we'll finish out here with Adam, and if we've got any other questions, we will get to them. All right, Adam, thank you so much for taking the time to be able to educate us on this, and I actually do feel a little bit smarter myself. I still don't feel worthy enough to be able to step out on a frac location, but I do appreciate your time. What else do you believe we should be able to educate the audience on? What are some other things that they should know, given y'all's area of expertise?
So I just want to highlight that a lot of our solutions, at Tetra, are developed as customers bring an issue to us. In addition to our flowback solutions, we have a very competent water management business that we've developed and delivered some differentiating technologies for years now. And almost always, it's the customer coming to us and saying, hey, we're having headaches with this or that, and it'd be great if we could provide a solution. We have a very capable engineering team that loves to sit around and think things up. So I would just encourage anybody and everybody who's listening that if you have an issue that we haven't highlighted here today, let us know. And we're constantly looking for another challenge.
Excellent. And what's the best way to be able to get in touch with you guys? Is it through the business development or y'all's engineering team? What's the preferred methodology to be able to contact y'all?
So we have a contact page on our website, and I'd encourage everybody to reach out through there, and we can get that dispatched to the appropriate people.
And it all sells. Obviously, we can all connect with you on LinkedIn, right?
Absolutely.
Especially if we're sending you Bitcoin Forex trading stuff, right?
There you go.
Because there's not enough of that. All right. Well, thank you so much, Adam, for taking the time here. I guess we run short of any questions from the audience. But I mean, I'm guessing Valdez is probably going to be giving you guys a call here pretty shortly to be able to get one of these out on his location, since he was the one asking the most questions. We do appreciate that. All right. Well, what can we be expecting out in the near future from Tetra Technologies? Anything else that you might be able to shine some light on?
Yeah, I think in the coming months, you'll see some more automation paired with the sandstorm technology. As I mentioned, the labor portion during the high sand production periods is the next big cost that I think a lot of operators want to focus on. The automation technologies have become more robust and more affordable, and I think the economics are compelling. It's something that we're focusing heavily on. We're actually deploying some systems overseas here in the next couple of weeks. So I'd be looking for that.
So we do have a little bit more time. Can you tell us about what kind of automation actually takes place over on the frac side?
Sure. So as far as the sand management side, dumping these traps is relatively easy. You need to control the flow, but you're basically just emptying them. And so it's a couple valves and a choke, and we've been able to automate that process very reliably. Obviously, if you're ever going to step away from an operation, you want to make sure that there are redundancies. And so that's what we've done. We've designed systems that are designed to operate remotely that are also still safe and reliable. And so, it's a series of valves and chokes and pressure sensors and tank leveling monitoring, all controlled by, a control system that we can then remote view through our online management system called Blue Links.
Excellent. Well, just here at the wire, we've got another question in from Carlos. Carlos asks, have you had success predicting sand accumulation to better size your equipment?
Definitely choke changes will affect sand production. So, there was a time where operators were really limited on how aggressively they could open these wells because the sand management equipment couldn't take it. Now, with us being able to capture so much and such high efficiencies, they're no longer limited by the overall sand production. So I would say that it may be difficult to predict exactly how much sand is going to be produced by changing a choke size, but you can usually expect to see some increases as you open up that choke initially. Really, the only change would be is how often do you dump this vessel, right? They obviously have a capacity that you don't want to exceed, otherwise you'll start seeing carryover. So based on the sand production that you're seeing, you may tailor your dump schedule from either every hour to maybe every half hour, or as sand production rates fall off, it could go to every couple hours or maybe even every 24 hours.
Excellent. Well, once again, how should everybody get in touch with you?
So again, my LinkedIn or reach out to us through our webpage, and Giselle is our marketing director, and she will get you sent over to the appropriate department, and we'll get you taken care of.
Well, thank you to everybody over there at Tetra Technologies, Adam, yourself, Giselle, who's back there, the behind the scenes, making sure everything's working for us. We do appreciate it. And for everybody out there that is watching, please stay tuned to SPE Lives. We've got more future tech talks. We're bringing you some of the best stuff here in the industry live here on LinkedIn and several other social media platforms. If you guys have any other questions, or if you guys have some other SPE Lives or Tech Talks, things that you would like to be able to hear about, please reach out to us. You can reach out to me or anybody else in the SPE staff. And we love to be able to bring you these kind of Tech Talks and informative sessions to be able to help you grow your knowledge in the industry. And as I always say, know your industry.